it's time to go, and as mentioned this morning, we have a jam-packed agenda, so we will crack on. So please grab a seat, and we'll kick off on session 2, which is about productivity, profitability, and quality considerations. So this session will take us through to lunch, and we will cover those broad senses of quality, profitability, and productivity. We have 2 farming case studies to delve into, an overview of Dairy High 2 farm trial, as well as penetration, a presentation about the Whenua Haumanu trial in New Zealand. Hopefully I pronounced that reasonably accurate. But Danny, I'm sure you'll help me out. So let's kick off session 2 on productivity, profitability and quality considerations. And leading the charge is Kate and Pete Myrant.
You got the name right, Rick. Anyway. Peter Neves and...
Hi, I'm Kate Myrant.
We are dairy farmers at Newry in Victoria. We milk 320 cows here with our 3 sons and 2 lovely staff.
Yeah, we've been here 21 years, and during that 21 years we started off farming pretty conventionally, and over the last 5 years we've really begun to learn and implement more soil-friendly farming practices.
We've become particularly passionate about regenerative agriculture, farming to improve soil, and farming to enhance soil microbiology.
We both come from a scientific background. We have both been lucky enough to be sponsored by the dairy industry to do masters in agriculture, and we worked in this space. We had the opportunity to see hundreds of dairy businesses before we started our own dairy business. And then as we started to realise the importance of changing the way we farm, we took a scientific approach to that as well. So we laser graded this area here in the summer of 1819, and a very hot, dry summer. The soils here were pulverised. It was a bit embarrassing, but it was also a massive challenge. And we wanted to learn how to very quickly ameliorate laser graded soil.
For setting up the trial, we started with 3 paired bays, so there was 6 bays involved, and 3 conventional and 3 regenerative. All in a reasonably close area. A set of bays gets monitored for total pasture consumption through the year by pre and post cuts, and also the quality of the feed's doing each time as well.
Additionally, we've got soil moisture probes in each bay down to 60 centimetres, so we can see infiltration of rainfall and irrigation water, and we can also see what depth roots are drawing water from.
We have seen quite an increase in the infiltration rates, and definitely the soil moisture probes are showing penetration of roots down to 60 centimetres and water being drawn up from that depth on the regen bays, whereas the conventional bays are only drawing water from 20 centimetres at the most.
When we compare the conventional bays to the regen bays, one of the things that stood out is really how similar they are in terms of the feed quantity grown. The regen bays are consistently higher bricks, which is a measure of the sugar content, and they are consistently lower nitrates, which is important for animal health because cows are not using energy to get that nitrate out of their system. So it's a better quality feed for cows, but we're growing about the same amount.
To me, another really big surprise is when I was irrigating here, running the 2 bays simultaneously. I came back 2 hours after that and found that where the regenerative bay, the water had soaked fully in, whereas on the conventional bay right next to it, it was still sitting on the surface. And that was a good indication that the soil structure was improving.
And this is really important because when the soil surface is waterlogged, which is what's happening on the conventional bays as they take a day to dry out and drain, pasture growth stops and the microbes are having to live in anaerobic conditions and perhaps dying. Whereas on the regen bays where it had soaked into the soil, there's still air in that soil. Plant growth won't stop and microbes continue to thrive. When we gave the multi-species crops really long recovery periods, we saw amazing things happen at the soil surface. The description is the soil surface has boiled. It turned over and aerated and looks amazing from the activity of worms by leaving the crop really, really long. And we love that, but we don't like the crash in milk production on too mature crops. So we've had to try and learn what's the compromise between achieving that soil surface aeration by a long recovery period and having good enough quality feed that we're making milk out of it. One of the fabulous things about having this trial hosted on our farm is we've had the data. We've had data showing us how much feed is grown, we've had data showing us the quality, we've had data showing us how much water is being used, the depth of that water, we've had data showing us what's happening to the soil nutrient status, and we've also been rigorous about collecting how much does it cost us to do every practice that's happened here, and that's given us a huge amount of confidence. So driven by the data, we've had the confidence to take this across our whole farm, and that's the focus on sulphur, boron, silicon and other micronutrients, as well as the potassium and phosphorus that a normal farm would focus on. Farmers moving into this, we've personally felt, and we've seen other farms with huge enthusiasm start down the road of reducing their nitrogen. Comes about May or June and there's a panic attack because they're not growing the feed that they need to be growing and that they're used to growing with high urea. And so I think that the off-ramp is really, it can be precarious. It's not like you just wake up one day and say, oh, we're going regen. There's a number of steps to get right to gradually move yourself from the high nitrogen input system to a system that's lower nitrogen but got heaps of other minerals going in. And I think that's really important to know that you're going to have a transition journey. And for us, it's been about 5 years, and now I'd say we're fairly confident that we're through it. But be ready for the journey, but also be ready to access as much support and information as you can to get there.
Okay.
Okay, good morning.
Morning. Any questions?
It's a huge honour to be invited to speak here and to share a little bit of our journey. We don't think by any means we are full-on ecological regenerative farmers, but we learn a little bit. And in honour of the hundreds, maybe thousands of farmers who've taught us how to farm, we respect this opportunity to share what we've learned with you.
Matthew Evans, when we took round down his farm in Tasmania, he said that one thing he said was, don't organise a conference if you want to hear things, because you won't have time to listen. But Kath's here listening at the front. Thanks, Kath, for all your work you put into it. It's amazing. That video took actually 6 hours to produce.
That was just our contribution.
Plus all the editing and everything, so there was a lot of work in it. Yeah.
The other thing Matthew Evans said, just while we're quoting Matthew, because he is our dinner speaker tonight, is the magic of an event like this is your conversations. Your conversations, your aha moments, your, oh, I must follow that up later, the things you learn from the people sitting next to you, the way that you embrace the journey and getting onto it and getting into it and your curiosity. So, yeah, look, this is just one story and what's coming is your story, and that's the most important part. Let's start.
That's what I was going to say earlier. Yeah. Okay, today we're just going to cover basically what we've done. A lot of the detail we won't cover today. We've got another session tomorrow where we'll try and bring that out. So you probably get more questions than answers today anyway. So we're doing it. Go on.
So that's just there was a conversation from Greenham's about outcomes verification rather than inputs verification. Our farm is verified, ecological outcome verified, and we could sell our milk as ecological outcome verified. This is a verification that's a worldwide standard that is used, developed by the Savory Institute, and we're very lucky enough that our milk company, Freshstein, covers the cost of doing that. So we know that our land year on year is becoming ecologically better.
All right,
They're not great on technology, as you've probably seen.
trying to do this and that. Anyway, we did summarise it before. We've got 106 hectares irrigated, plus we've got a runoff block now that we purchased last year. 320 cows, 525 milk stocks a cow. We try to focus on maximising homegrown feed. Stocking rates around 3 cows per hectare. We try to put in about 4 tonne of feed, wet grazed, and with the top up to do the concentrate and a bit of hay. Heaps of trees and waterways that we've fenced off, as well as now moving into this reasonably top space. We've already got 51 paddocks, so Something that you see a lot of other types of farmers, beef guys are doing a lot of work in grazing only. We're lucky at dairy farmers that have already got the grazing going. It's easy for us to have a rotation and allow the pasture to recover. So we're already sort of on the way, which is an awesome start for dairy farmers.
Okay. Yeah, so you heard that we had a trial established in 2019. You saw the trial area, that's the newly lasered area that you saw in the video going. Those 3 areas outlined in red there are the bays that have had the regenerative treatment. The bay to the right, beside each one, is the conventional bay. So we're not going to tell you a lot about what the treatments were just today, but we will go into it more depth tomorrow. So the conventional just had monoculture, annual winter, annual summer, and then just a perennial ryegrass sown into it. It has urea, super and potash. The regenerative bays had multi-species, annual winter crops, summer crops. They had seed coating with minerals, biology, fungi, and fungi-friendly nutrients supplied. Okay, so the things we measured the pasture harvested, energy, protein, fibre, tissue pests, the nitrates, bricks, annual soil tests to 60 centimetres, and soil health indicators, and we also have soil moisture probes down to 60 centimetres. So again, that's not what we're going into in terms of the data. That's just what we wanted to give you a background of a sense of what the regen style of management that we're using is. So what do we learn from the trial?
So you can see there, we've monitored the feed produced. We are confident we weren't getting any less feed from the regenerative paddocks from the monitoring we were doing. The fibre and crude protein levels were similar. This year we're in now, we haven't got the data to show, but after the 5 years we're seeing considerably better results on 2 of our regen bays compared to their mates in the conventional. One of the other bays is basically the same. Essentially we've been able to produce milk from the multi-species pastures, which gave us a lot of confidence to move on to the whole farm. So here's a list of some of the stuff that we stopped doing. Cultivating, fungicide on seed and pesticide on seed, so we basically have to source some bare seed for our plantings and then apply some Nutrisoil or other things onto them to try and make a better environment for the bugs in the soil. As soon as the plants started to grow, we're going into a friendly environment rather than an antagonistic environment. That was something it's cheap to do and something we think is a real no-brainer. So putting in salt super, muriate of potash with the chlorine, we believe it's a killer of prickly fungi, so we stopped using that, putting in SOP instead. And bare ground and short plant recovery times, we basically extend the rotations a bit, but we have had trouble with going too long with the rotation and then compromising pasture quality. So we tend to do it more in sort of when putting in a new crop. We'll give that a long time, might be 12 weeks before we graze it. But the normal round is pretty much through the growing season, 25 to 30 days. And we're fully irrigated, so if we go to the 60-day round, which we tried to get, it was a bit too rank. So some of the things we started doing, obviously the multi-species, we started using topping up paddocks instead of fully re-sowing to try and keep the living roots in the soil. Microbial seed, so on and so on. Foliar end, so we haven't gone totally away from using nitrogen. Urea, we use it in a toe-and-fert machine instead. In that machine, which we'll probably talk about a bit tomorrow more, but the toe-and-fert machine is sort of our way of getting nutrients on there. We put on small amounts of urea, small amounts of SOP, and a soil bench which has lots of micro trace elements in it. Which, so essentially for the year we've cut our urea rates way down, and we'll show you that.
Okay, so what we want to share with you, the main part of our talk today is about what's been the whole farm impact on our farm. So the 4 areas we want to share, sorry, 2 minutes. Holy badooly, here we go. Rightio. This is our discussion group we have in Mafra. It's actually run by Fiona Smith, who I thought might be here today. This is the pasture consumption across the 9 farms in our discussion group. We are farm 4, so you can see our pasture consumption has held up. Go. This is our annual nitrogen application per year. So it varies in the group from 437 kilos of nitrogen per hectare down to our farm, which was 29 in that year. Go. This is the annual. This is how we compare, just putting those 2 figures together, so you can see we've been able to hold up our pasture consumption despite our nitrogen going down a fair bit. Go. Go. Now, this is the graph we want you to remember. This is how you're going to remember it. Can you all just do that, please? Rightio. So what I want you to look at there, this is the kilograms of pasture or tonnes of pasture grown per kilogram of nitrogen applied. So you can see across the industry sitting around below 50 kilos of feed grown per kilo of nitrogen applied, and we have been able to achieve between 400 and 450 kilos. Just keep that in mind. Okay.
So the last 6 years, what we've done, you can see, we're going to run through that. Number of cows with milk, we haven't cut back cows, we've increased cows. Grown rate consumed over the last 6 years, sort of around that 12 tonne. Last year was down a bit because of a particularly poor year with flooding and so on, which is the same as on their other farms in our discussion group. So we've reduced our nitrogen. You can see the line there is the amount of nitrogen we put on per hectare, gradually reducing from 200 kilos down to 20 last year. So we started off by reducing, just putting in some folic acid carbon source. Then we found we could consider doing 3 hectares of the nitrogen. We do it on 4 hectares, and you got the same result. Gradually went down. The last couple of years is where we started using foliars through advice from Joel Williams and other people like Nicole Masters. The foliars have been sort of one of our main keys in the last few years. Just one thing, that Nicole Masters books up the fact there I see at the Nutrient Soil tent. Get a copy of it if you can. It's one of our key references. So milk solids has gone up through the journey, and return on assets been pretty solid over the last 6 years. Last year was down a little bit, mainly because we bought another $2 million farm down the road, which I don't see the figures, but it doesn't really do much. And that's it.
Well done.
Peter, I think I'm going to need that clicker.
Oh, yeah.
Hello everyone, thanks very much. We're going to crack on here. My name is Gillian O'Sullivan, and I'm really honoured to travel over here and to be invited here by Dairy Australia, and massive thank you to them for giving me the opportunity, because it really does mean a lot, and I'm delighted to be able to chat to everyone. So I'll try and be relatively quick about this, but look, my big message today is to get across why we got into changing our farm system to include multi-species words and what that has brought to us. So this is us. I'm married to Neil. We've got 4 children, and we farm in the southeast of Ireland. And I guess the way both myself and my husband are both vets, and we just like Peter, and we have a science-based approach to how we farm. So we milk about 100 cows, which is average, sounds small, but average herd size for Ireland on about 60 hectares, and it is quite a beautiful spot. Like, it is really, really beautiful. We're overlooked on Garden Bay, but it does come with its challenges. So we work off this amount of soil on parts of the farm, so that's our topsoil. It's about 2 to 3 inches before where that ruler is hitting is basically subsoil or rock, and that's a soil pit there on the farm, and you can see, yeah, it's pretty stony. So other challenges we face would be, you know, that tractor didn't fall up the hill, that's where it landed when it went down. So it's it is a challenging farm, and other challenges that we come across then is something that you guys are probably a little bit more familiar with, which is that summer dry spell. And I know that relative to Australia, what Ireland calls a drought or a summer dry spell is, we're talking about two different things here, but occasionally we do have a summer dry spell. And on our farm it's a little bit more pronounced because we're working with less soil, we'll say, on those south-facing, very, very steep slopes. You're going to end up hitting this kind of thing every now and again. So during that spell where our farm turned that colour, I was at a conference, and this chart came up, and basically what it shows in this chart, the frequency of extreme weather events that occurred globally, and it is those 3 different colours represent storms, floods and drought events that have occurred over the last 40 years globally. So I'm a child of the 80s, and so this starts from 1980 at the bottom, and as you can see, so over the last 40 years, the frequency of those events, of those extreme weather events, has increased at 3-fold. So that is, you know, as a farmer, that's quite a you know, that's quite an important thing to have on board. And for us, when we were farming for a number of years, we could see that these, I guess, these uncontrolled, or events outside of our control, were impacting on farm profitability. It set us about thinking about how could we design a system that could be, I guess, less, that could minimise those risks that were outside of our control. So the main risks we could see is, so we've got control over costs, relatively, and then on the other side of it we have market volatility, and we have environmental regulation, which is a big thing in Europe and in Ireland, and we have weather extremes. So we wanted to look at those 3 factors and see what we could do around that and how we could mitigate that. So first and foremost, obviously, the weather extremes. And what happens with weather extremes, we get increased purchase speed, obviously increased cost as a result, increased labour because you have to feed all these things out, and obviously increased stress, and everybody feels that when things get a little bit extreme. And how do you offset that? Well, you know, you could. That's you know, that picture is a ryegrass pasture. Ryegrass has all of its roots kind of pretty much contained within that top 3 inches. So we could change our pasture species to bring in a little bit more resilience. We could look at our stocking rate and see how we could maybe address our stocking rate so that we bring a little bit of extra resilience in, adding a little extra couple of days maybe to reduce our farm demand. And again, looking at costs. So what is the long-term risk or the long-term outlook around weather extremes? Because we've already said there, it's predicted, especially in Ireland, hotter, drier summers, warmer, wetter winters. And that's how it's going to be for the next 20 to 30 years. So the risk is going to be increasing over time. Second one, about market fluctuation. So I know that you guys are exporting milk, just like we do in Ireland. We're exporting about over 90% of the milk we produce. And there's 2 things here in relation to market fluctuation. So you've got control over on one side, so you've got milk price. And how do you control your milk price? Because, you know, global markets influence your milk price. So how do you, for us, we looked at milking once a day, and we have really top-tier genetics in our herd. So focusing on that excellence in terms of the cows that are going to be on your farm are going to be high-producing cows. They're going to have high fat and protein percentages. They're going to be driving your milk price. On the other side of it, we are on the, you know, when it comes to fluctuations in market, how that influences your farm input costs. We can see that, you know, in terms of, like, a couple of years back, we had a 3-fold increase in our fertilizer costs just because of, because of global geopolitical events. So how do you offset that? Again, it's looking at reducing your reliance on purchase costs. So things like nitrogen, obviously. So again, looking at low nitrogen requiring swards, looking at reducing your reliance on purchase feed. So looking at producing as much feed as you can from within your farm gate. Again, the long-term risk in terms of market fluctuations, it's looking like, well, you can see what happened this week with Trump and tariffs and things like that, and geopolitical events. Again, we're looking at a future of increased risk. This is our farm milk price over the last 10 years, and you can see there's that's in cents per litre. On average, that's 48 cents per litre, which is, I think in Australian dollars, about 80 cent. Does that, hopefully that translates to you guys, but so on average, that's our price. So it maximises our milk price over the last 10 years through genetics and through, we'd say, and through once a day. And it gives us about a 10% or 10 cent a litre on top of other farms that are producing milk in the same area. So it's a great margin to be working with on a consistent basis. Again, around environmental stuff, we have in Ireland huge level of costs associated with environmental policy and regulation. We have, we have a register for fertiliser, so every time I buy fertiliser, that goes straight through from the merchant to a centralised database. Every kilo of nitrogen is allocated to our farm. We have regulations for water quality. There's big pressure on for emissions, farm emissions. So these things are very, very pressing. And how do you offset that? And so again, it's looking at lowering your end inputs, because what drives emissions, it is cow numbers and your nitrogen usage. Looking at your stocking rate again, trying to produce as much feed as you can from inside the farm gate, so you're minimising your purchase in feeds. And again, reducing your reliance on purchase feed. So when we look at these, again, risk, looking at the long-term risk from this one, is that going to increase or decrease over the next 30 years? Certainly from where we are, and my perspective, that's going to become a bigger issue. So finally, multi-species swords, when we put all of these things together, common threads were coming through. And what was emerging was that offsetting these risks certainly came towards low nitrogen requiring swards. And here's our first attempt at multi-species. So we mapped out the farm. We looked at areas of the farm that were most prone to drought, and we put in multi-species swards. That sward is a 7-species mix: red clover, white clover, ryegrass, timothy, fescue, plantain, and chicory. And it looks like salad bowl. Like you could eat it yourself. It's incredible. But the big story really from that is, how does it fit into the farm system when things get a bit extreme? Again, this is the big steep hill there, and we have, after a dry spell, on the left-hand side, you can see all of those species started to go yellow sequentially, depending on how their rooting depth was. Obviously, the ryegrass died off pretty quickly, but you have the pasture species that are left behind there would be your chicory, your plantain, and you can see rain occurred that first evening. 12 days later, you've got a really, really fast recovery. And what does that look like relative to ryegrass? It's the same paddock that we looked at, but we say over the ditch was a ryegrass paddock. And you can see I stick my runner in there as your benchmark. The recovery is much, much faster from a drought instance or a dry spell instance. I can't use the word drought in Ireland, can I? So we have, it just bounces back that bit faster. And why is that happening? Well, simply because of having roots. And you can see that chicory root there. I can't get the spade further down from where my fingers are, and it's going straight down through. That's going deeper and deeper than you could go with the spade. So let's put some figures around that. So this is one of our most challenged fields on the farm. On the left-hand side, that's when it was conventionally managed. And I know that this, the growth and tonnage there seem very, very low, but this is a very marginal field, and what you get off it isn't, it's never going to be massive. So with 200 kilos of N and would say, and a ryegrass sward, you were getting about 6.35 tonne per hectare on average. And So that's from 2016 up to 2020. But the quality of that pasture was, if it gets dry, ryegrass loves to put up seed heads and stem. The cows go in there, they run around for a bit, and then they go back up to the gap going, yeah, I'm not having any of this, guys. So it's, it was, in terms of pasture quality for cows, it wasn't amazing. So when we went to the multi-species side of things, we have similar growth pattern, but with much less nitrogen. So you have less than 50 kilos of nitrogen, you're growing a similar tonnage of grass on very, very challenged hills. So we don't even have to bring the tractor down there now, like there's virtually nothing going out on it. And you're getting much higher quality pasture. So in terms of utilisation, I'm doing similar production on the most challenged and marginal aspects of our farm with lower inputs and higher quality feed produced. So really, it's a no-brainer. And relative to the rest of the farm, just to say, our farm, it's a challenge farm, but we grow on average between 8 and 12 tonne, depending on the year. But that's where we started, was the most challenged part of our farm. So what does that look like for relative to, say, the national average dairy farm for 2023? I put the Aussie figures in the bottom there. So National Farm Survey data is put out every year on production and performance from herds, and this is data that, so I guess net margin is the figure you really want to look at. But when it comes down to, we have milk price, our milk price there is again 10 cents a litre ahead of the National Farm Survey milk price at 52 cents a litre in that year. Similar production for milk solids. We have similar output in terms of nitrogen. Our concentrate per cow is a little bit less, but most significantly, cost per cow here is pretty much half. And how does that look in terms of net margin? Double the net margin per hectare. I mean, it's a very, very robust system when you're focused on your margin, and that's the most important thing, that you're retaining a significant margin in every litre that goes out the gap. So yeah, and everybody, you've seen this is what our multi-species wards look like. And it's all backed up by research. So research then has, Zoe, my colleague from Ireland, she's also involved in UCD. They have research to show that the multi-species wards outperform ryegrass and are more resistant to drought. Lambs on multi-species have a 24% higher average daily weight gain. Beef heifers on multi-species had 13% higher daily live weight gain over ryegrass. Research and dairy farm system trials in Chagas show an 8 kilo of milk solids per cow increase in production, but with lower costs and, more importantly, greater environmental benefits. So greater carbon sequestration, we have greater plant root mass, with greater levels of below-ground biodiversity in terms of earthworm activity in nematodes, especially predatory nematodes. Reduced nitrate leaching due to the effect of plantain on nitrogen excretion in cows' urine. And when it comes to farmers mitigating risk and creating farm systems that we have more resilience in than this, you couldn't overlook this. So we've also tried, as the guys were saying, we've grown up our species really, really tall and just given it, experimented, put them into high covers on multi-species. Yes, it does impact on milk production, but what we were doing is trying to build a bit of cover on a really steep hill. We've also tried red clover, white clover, and ryegrass, a super mix. We didn't get bloat on that either. It's just, a lot of that is about management. And again, we've also tried the summer grazing on a year of reseeding. If we're doing something to improve soil structure, we put in a summer grazable crop that has Phacelia rye, linseed, clovers, stubble turnips, fodder radish, rape, and mustard. So it's a big mix. And the idea here is to push a bank of feed into the summertime for when it gets dry, and then graze that. And as soon as that's done, then you're getting in either a clover or a multi-species sward right in after it. And so my take-home message is farming is about calculated risk management. Risks are increasing in our current environment, and the uncontrollable versus the controllable risks, we have weather policy and farm input costs and market fluctuations. So Research in Ireland showed that 45% of the difference in profitability between farms is related to the cost of production, so that's a really, really key focus. And targeting a consistent profit margin with a simple farm system is where we approach it. So that involves low nitrogen swards, and multi-species and clover swards are a big part of that. Excellent genetics to drive production, and creating a really top-tier work-life balance. So what I would like to ask, the last thing I'll say to you is, what is the definition of insanity? It's doing the same thing and expecting different results. And can we afford to continue doing the same thing in an environment of increasing risk and expect the same results? So thanks very much.
Okay. Can you hear me okay?
No, it's not on.
Not on? Oh, my lord.
Joe?
Is that better? It's, yep, okay, all there. Very good. Hi. For those who don't know me, I'm James Hills. I work at Tasmania Institute of Agriculture down in Burnie, on the northwest of Tasmania. It's a beautiful place. There's a picture there of our farm, bringing the cows into the dairy in the morning. Great place to come and visit, but a great place to farm. And we love it. That's our office. So very similar to what was presented for Ireland, that very, very lovely places when we're out there with the cows. What I'm going to do today is just give you a little bit of an update of the research that we've been doing in collaboration with Dairy Australia around our farmlet study. So we've set up a really large farmlet study which runs over 3 years, looking at 4 mini herds. And the aim of that work initially was to basically look at whether we could achieve high productivity. This is a fully irrigated system. Whether we could achieve high productivity, so 2,000 kilos of milk solids per hectare and about 20 tonnes of pasture dry matter per hectare with about 150 kilos of N. So in the system that we operate in down there, on average we use about 300 kilos of N in a fully irrigated ryegrass system to produce that sort of tonnage of feed. And so we're saying, well, okay, if there's going to be limitations to inputs and there's a need to be able to move away from those high levels of inputs, what impact is that going to have on our production system? And can we achieve productivity similar to that by just changing our system? So the strategy really was to look at increasing species diversity and looking at biological N fixation within those systems. So we were measuring a whole heap of things within those farmlets over the 3 years. We're about halfway through now, 1.5 years into it. So pasture grown and utilised, pasture species compositions, what's happening to those compositions over time, milk solid production, and then a whole heap of measurements around soil health. So that's what we're currently working on. So just looking at the 4 farmlets that we have set up. So the first of those farmlets is the conventional farmlet. So it is just a ryegrass legume mix, 80% ryegrass, 20% legumes is what we aim for, with 300 kilos of N. So the typical commercial program. And then we said, okay, well, let's have a look at the next farmlet, which is just going to be exactly the same except 150 units of N. What is going to be the impact of production in that scenario? The third farmlet that we set up was saying, okay, we think there's going to be an impact on production based on the reduction in N. What can we do to try and overcome that? And so we were looking at increasing the legume component slightly and also introducing some of the herbs because of their properties around dealing with N and so forth. We've already been hearing about that. And then the fourth farmlet, originally we didn't have 0 N, but this particular farmlet, with the challenge from James and others, was why don't you really test this system? And so the fourth farmlet is one where we're using no synthetic N input at all, and we were increasing the diversity of that. So similar in terms of the proportions, 40% grasses, 30% legumes, 30% herbs, as farmlet number 3, but more diversity within that particular system and no N. So that's the system we're working with. So 32 hectares of the farm was set up for that. 8 paddocks of 0.92 hectares each for each of the farmlets, and that was spread out across the whole area so that we blocked it really well so we could make sure we could manage for any variability as a result of area or geographic location on the farm. And farmlets 1 to 3, we put in 29 cows per hectare, so that's 4 cows per hectare, 29 cows in each herd. farm at 4, we only stocked it at 3. That was probably because we weren't sure that we would grow as much pasture in farm at 4 as the others, and so we wanted a relatively stock rate. We didn't want to buy in a whole heap of feed and then import in a whole heap of nitrogen. So we said, okay, based on our modelling and what we thought would happen with farm at 4, we would stock it at a lower stocking rate. So that's the reason for the difference, 29 versus 22 in those farmers. What I want to do is just quickly take you through some of the work we did to establish those farmlets and those paddocks, because it's really important in the story that we're telling and the productivity that we're seeing. This work began way back in March 2021, where we grid soil sampled the whole of that 32 hectares, and then on the basis of that, we then variably rate fertilised that whole area to try to make sure that the what we were starting with across the whole area was the same. So that when we have each of the 4 farmers, they were going to be similar and there wasn't going to be an issue with differences in fertility. And we wanted to make sure that the nutrient levels were in a range that was not going to limit production. So some of the things we did, I mean, on average, we applied 7.6 tonnes of lime at that time. Now that ranged from about half a tonne up to about 12 tonnes, depending on the requirements across that area. But essentially, no, we had a pH from that area. It was our runoff area from the old dairy, so we shifted our dairy across to this area, and then our pH was about 5.6 or 5.7 initially. So we certainly wanted to make sure we could change that to make it conducive to pasture production. Put in 170 kilos of phosphorus, 98 kilos of potassium. That's in the initial stages, and then we planted an Italian ryegrass over that area at that time. And then we grazed that, made silage out of that, and then installed all of our irrigation, so we had an irrigation system in there. And then it was in March 2022, a year later, that we actually planted our farmlet paddocks. And there's an example of a process that we're going through to do that. What we found is that it wasn't very long after we established our pastures that we had a major issue, and that was weeds. When you start to particularly put in multi-species and you're limited in terms of your chemical control options, we had an issue with weeds, and so we decided we had to go in with a broadleaf spray program to try and rectify that, which meant we had to terminate our clover in our system. So we did that between June and September 2022, re-sowed the clover from September to October 2022, and then what you'll see in these pictures here is Cape weed was probably one of our major weeds, and fumitory, and there was just about everything else there, so it certainly wouldn't have been conducive to doing the trial work with all of those weeds. We had to deal with them. And then we had to get our clover back into our ryegrass. And everyone told us that if you get clover back in when you've got an established ryegrass pasture, it's not going to be very easy. And so we went pretty hard. And we scarified it, made sure it was well grazed down so that we could then direct drill our clovers into our pastures. So we resowed our clovers, topped up with a number of the other species, and finally, in July to August 2023, we introduced our cows. So there's a long journey and a lot of learnings that went through that period of time. Now, we ended up with paddocks that look pretty good as a result of all that effort to go into. What were we aiming in terms of composition? So in farmlet 1, obviously 8% ryegrass, 20% clover. Similar in farmlet 2. Then farmlet 3, we were aiming for more clover and some plantain. And then in farmlet 4, we were aiming for a much more complex mixed species. That's what we were aiming for. What do we have now in July 2025, in January 2025? So we've got about 70% ryegrass and about 30% clover. We were very successful in reintroducing that clover such that we've got a lot of clover in our system. Farmers 1, 2 and 3 are fairly similar in terms of ryegrass. Clover is around that 70% and about 30% clover. Plantain, we started with about 15% when we had it initially established. We're down to about 2 or 3%. We're certainly not in that system able to maintain that plantain. And we've topped up, we've tried a number of things to achieve high levels of plantain. We don't seem to be able to do that. And in farmlet 4, our ryegrass has certainly increased. Clover's sitting a bit higher, really up closer to 40%, and our copsewood certainly seems to be increasing over that period of time. So that's the botanical composition of the farmers. Just some production results. So our aim was to achieve 20 tonnes of pasture grown under that fully irrigated system, and we assumed we'd get that with farmlet 1, perhaps with farmlet 3. What we found after our first year of results is that we achieved 20 tonnes across all of our four farms, whether it was mixed species with no N. And just to comment there, we obviously worked this whole area up, and so there was a lot of organic matter went into that. That was back in 2021. So the whole impact of that extra pasture being worked into the ground, that extra organic matter, from a nitrogen perspective, is well and truly gone. So we're really seeing the impacts of our treatments at this point, now in 2025. But the pasture grown there was about the same. This year, we're tracking similar, but just slightly behind in terms of our total production. And when we modelled that using dairy mod, what we were able to show is that the pasture grown in kilograms of grown matter per hectare per day, so the blue ones is 23, 24 up to January, and then the same period for this season. It predicted that we'd achieve about 14.6 tonnes, the model, and we grew about 14.5, so we're pretty close to it. For this particular season we're in now, it predicted only 13.5 tonnes, and we're about 13.7. So the difference in production is more due to climate than it is due to our management, so seasonal differences. So certainly we're seeing that, and when you actually look at the pasture growth rates on this, this is kilograms of dry matter grown through the season, from July through to June, so it's each week. We certainly see that the dotted line is 23, 24, and then the solid line is this current season. We can see the differences in that pasture growth, and it lines up with what the model was suggesting. So it's very much a climate effect. Our production in terms of cow production, we want to achieve about 2,000 kilos of milk solids per hectare. That's where the red line is. We achieved about 2,400. So we certainly achieved a lot more than what we estimated, and that's on 70% grass and 30% in terms of grain and our silage. Farm 4 though is obviously a little bit lower because this has a lower stocking rate in terms of milk solids per hectare, but the milk solids per cow is the same for each of those treatments. So in farm 4 we were producing less milk, but we were producing a lot more silage, and so that's the combination of those in that particular system. So just quickly some discussion, how are we achieving this production similar to model potential? Well, the first thing we did is we removed nutrient limits within the system before we started. It wasn't a matter of, oh, we're just going to turn off the tap and move to something. We actually did a lot of work to make sure we were in a position where we weren't going to limit production, and we also made sure that through management we weren't limiting due to water. So we were doing some very close monitoring of irrigation, and we're making sure that we're keeping that irrigation up so that we're not limiting as a result of moisture. And so I think we've got probably about 20 or so probes right across that whole site, monitoring across all of our farmlets what's happening right down to 80 centimetres. And then if you look at our soil nutrient levels, we wanted to keep everything in the ideal, so not only do we do all that work early on, but then we do soil testing in March every year, and then we do fertiliser applications twice a year to be able to maintain our nutrient levels, apart from nitrogen, those levels that are ideal. So pH now is about 6.5, so it was about 5.7, it is now 6.5, so certainly it's lifted into a very ideal range. Ulcin phosphorus, around 20, potassium, coal potassium is 240 odd, so it's right at the top end of that range, and our sulphur is certainly very high as well. That's just a snapshot, but essentially we're monitoring that all the way through. Farmers 1, 2 and 3, we're conventionally fertilising. So we're putting in our normal phosphorus, super, and we're putting in muriate of potash and those sort of things, and urea. So that's a typical program. In farm 4, we're still maintaining our levels, but we're using things like guano phosphorus, we're using sulphate of potash, and so there's some alternatives in terms of what we're doing in terms of managing it, but we're making sure that we're not limiting our production within that system. So what about the nitrogen story? Where's nitrogen coming from? If we're putting no N in farm 4, but we're actually achieving production and not seeing any impact on production. So when you look at the results from our sampling, we take grab samples every single grazing round, right across all of our farmlets, and we look at that. So for 23-24, the average crude protein in our pastures for all the farmlets was around 23.5, and it's exactly the same for all farmlets. So the plants are obviously getting nitrogen from somewhere, and it's similar across all of our farmlets. Whether you put 300 units of N, we put 0. Milk urea nitrogen, that's a really good measure of what is happening in terms of what the cows are eating and the nitrogen that's going in. So what you've got there is you've got your lower line, which is anything below that red line is there would be a deficiency in the amount of nitrogen in there. Anything above the top line is excessive. What you can see is for each of our farmers, 1, 2, 3 and 4, right through the season, we've got adequate or excessive N in the system. So that's pretty clear. We've done some work to look at where that's potentially coming from. We've done some work with our nodules. We've looked at the activity of rhizobia, and we certainly can see active rhizobia across all of our farmers. Doesn't matter, farmer 1 right through to farmer 4. We've done a bit of work with looking at what exists there in terms of the microflora. There's a lot of nitrogen-fixing bacteria there present, so obviously it's active and it's present and it's doing its job. We've done some microbiome analysis. We're looking at the abundance of microbes under the soil, and what we've seen in our baseline measurements is that we have plenty of it, and it's similar across each of our farmers, which is where we want to be to start with. We'll do another measurement at the end of the trial in 2026 to see what changes potentially have occurred over that time between our different farmers. Let's just quickly go through the N on farm at pasture story. So we know that we've got 23.5% crude protein. We know that we're growing about 1,500 kilos of dry matter. We know that we're applying in farm 1 30 units per round per cycle. There's about 10 of those rounds a year, so 300 units in total. 150 on farmers 2 and 3 and 0 on farmer 4. Our recycle from our cows is estimated around 23 kilos for farmers 1, 2 and 3 and 18 for farmer 4 with a few animals. We know we need about 56 kilos of effective N per round to be able to grow that 1,500 kilos and achieve 23% crude protein, which tells us that we are getting nitrogen in that system from somewhere, particularly with farmer 4, about 38 kilos per round, or about 380 kilos in the season. So that clover in that system, or whatever it is, the microflora, whether it's the free living, all that, it is adding a lot of nitrogen. It is crucial to that system and the ability of that system to function. And I believe at the moment it is the clover. We've got some PhD projects where we're looking at the source of where that's coming from, as opposed to nitrate fixing via free living or via the symbiotic. So there's some work going on that to be able to identify some of that. Just quickly, the benchmarking, the preliminary findings. We've done a little bit of benchmarking with working with FarmMax. We've used our dairy farm monitor data as some of the data in the benchmarking we've done to compare between our farmers, and we've benchmarked against 70 farms from New Zealand because it's a part of the FarmMax package. What we differ in terms of some of the costs is labour, because the fewer animals in farm 4 means a slightly lower labour cost. N fertiliser obviously is different. The different N levels, and then some of our other fertiliser costs are different, and things like low drench and so forth. We haven't seen any bloat, by the way, across any of it, even with up to 40% clover. I think fully feeding your cows and maintaining that and having them conditioned, we're certainly not seeing an issue with that at all, but we still have bloat drench in our feed when they come into the dairy. If we just quickly look at this, the top line, operating costs. So we're working on an operating cost of about $5 per kilo of milk solids. Within those farms, based on the data that we've used within this modelling, compared to similar to what's happening in New Zealand. And if you drop down to the middle section, the milk price of say $8 per kilo of milk solids, plus some from livestock, so $8.45 we've got there. If you look at the operating profit across each of our farmers, so our operating profit per hectare is around 8,500 farm at 1, similar in farm at 2, 8,100, 8,300 in farm at 3, and about 6,100 in farm at 4. Now, again, the reason for the difference in the profitability per hectare in farm at 4 is that we were producing less milk because of less cows and more silage, and the silage wasn't worth near as much as the milk. So that's the reason for that. We're still getting the same production per cow on that particular one. So the operating profit per kilo of milk solids is very similar across each of those. So a very, very productive and a very profitable system based on the comparisons, but very little difference between each of them. So in summary, the data to date, it's very profitable and very productive. Pasture grown, no, we have achieved that stretch target of 20 tonnes. It would have been nice to have had the same stocking rate on each of those. We decided at the end of the first year we weren't going to change that, because being a scientific trial where we're replicating over years, we didn't want to change the stocking rate for our cows from year to year, so we're going to maintain that right through. But we are measuring everything, so we can always interpret that in relation to that. Our milk solids that we're achieving is extremely high, based on the productivity, and that is based on primarily the pasture side of things. And we've achieved it with low or no synthetic AMP. So we're certainly, at this stage, achieving what we aim to achieve, and we're going to have a look at how that may continue to persist for another year of data. And at this stage, for farm at 4, clover is likely to be the key driver of productivity. And so the challenge there is that it fluctuates over the season, and it may fluctuate over years, and if it has an issue with its ability to be able to be maintained, well then that could lead to that system not necessarily being as resilient as what we'd like it to be, but that's something we're obviously working through. And I think that's about it really. I don't think there's anything else. So I think I could probably hand over to Danny. His turn.
I have a microphone coming somewhere. Do I? I'll just yell. Is one there? Oh, no.
No, it's
Yeah, no,
using
no,
a
no.
roving
I'm going to move. Raving mic. What was that?
mic.
Roving. Thank you. Well, kia ora tātou, or g'day everyone from the land of New Zealand. I'm Danny. Thank you, Kath and the team, for inviting us here. Thank you very much. Also, starting off the morning talking about elders past and present, I'd like to acknowledge Peter Sale, lecturer from La Trobe University. He was quite inspirational and directly responsible for me being interested in research and having a career in research. So Pete, this is all your fault. I'm giving an overview of the Whenua Humanu program. So, oh no, press the right one, that's right. I use the same ones at work but never remember how they work. So Whenua Humanu means, Whenua is land, Humanu is breath of life in the literal translation in Māori. And what we've settled on is nurturing the land through exploring pastoral farming. That's what we work with the local iwi or Māori group, tribe, to be gifted a name. It's New Zealand's most comprehensive program around regenerative as well as and contemporary practices. It's funded primarily by the Ministry for Primary Industries. It's about $27 million now, with other inputs into the programs it's grown. 7 years, we're almost halfway through that, bringing together universities. So we invited Lincoln University as well, New Zealand's other agricultural university, the Crown Research Institutes, your equivalent of CSIRO, and the industry partners. So we set out to scientifically assess the suitability and relevance of regenerative agriculture to New Zealand, because a lot of the practices and the things that were being talked about at the time were very, very reasonable, you might imagine, in the Dust Bowl areas of the US, but when you come to a higher rain-fed area with some of the highest soil carbon in the world, what's the relevance to us, and what else can we still improve on within our current systems, because they're not right, and we haven't finished the pathway there. There's a focus on capacity and capability building as well with this program. The government were quite keen that we use it as a way to train a generation of students, I guess, around systems thinking and how systems work. And not just the current system, but alternative systems thinking as well. So 3 years in, we've got 29 postgraduate students. We use these farmers as a teaching resource. For the veterinary students at NAS, there's 175 of them. Animal science, there's 100 of them a year. And agriculture and agribusiness, about 100 of them. And same down at Lincoln. So there's lots and lots of students that are starting to cycle through these farmers. There's about another 8 or 9 postgrads coming this year. And we rely on them to get a lot of the detailed work done, because there's just not enough hours in the day, and I'm a lazy bastard. Here's a partnership in partners. We've got us and MPI, and then we've got a whole bunch of various companies in there. You recognise some of those names, including some of the regenerative groups like Quorum Sense and others that are heavily involved, and they support us a lot, which is much appreciated. So if you haven't seen this before, it's a map of Aotearoa the land of the wrong white crowd, as they call it. And Palmerston North, which is, wrong white crowd, I can't remember which. Palmerston North, which is down the neck of the North Island, that's where we're based, where Massey's base is. And then MPI, separate to our program funding, they fund a program over at Pukawa on the east coast, very dry soils at Pukawa, and that's looking at regenerative practices as well. Then Dairy Trust Taranaki in their Waimate West farm on the west coast. They're not looking at regenerative per se, but they are looking at diverse pastures versus less diverse pastures. And then way up north in Dargaville, again looking at resilient pastures in an area that's subtropical, and they've come to that conclusion that it is subtropical. And most of their challenge is about how do we manage within a Kikuyu pasture base, because you're not going to get rid of it. Down on the lower North Island there, South Island, you've got Lincoln and their site there. Maitahu, which is a multi-land corporation farming group that's looking at regenerative agriculture as well on a larger scale on dairy farms. And then Agricom have got a farm, a beef farm, they're looking at regenerative and degenerative practices. So they're working the shit out of the soil, pugging it as much as possible, high stocking rates, and then looking at how that affects soil structure and animal performance. Thriving metropolis of Palmerston North. These are our two sites. That's the mighty Munro 2 looking at Lynn Brown. Palmy's got almost 90,000 people there now, and Dairy 1, which is about 100 hectares, the project takes up 37.5 hectares of that, as outlined in the yellow. And then the Pasture and Crop Research Unit, there's 12 hectares right along the highway, and there's Massey's campus. The soil scientists, when they did the mapping, they said you've got 5 different soil types here. We know soil scientists lie. They always try to distinguish between a sandy loam and a loamy sand and a silty something. But nevertheless, they came up with some nice colourful maps. So the challenge was, these are all free draining soils sitting over the top of gravel. So it gets pretty dry very quickly. And the usual thing about drought in New Zealand's 2 days without rain, we do start to feel it on these soil types compared to heavier soil types. And so the challenge for the project was to fit all their treatments equally across soil type, and also to have equal distance, walking distance from cattle to the dairy shed, so that at the end, as the years rolled on, there wasn't one treatment that was prejudiced or supported over another. The other thing I didn't point out there is you can see a footbridge. So the Hiaragatahi walking track, which is part of the National Walking Trail, comes right over, and there's 2,500 to 3,000 people come across there every day. Some of them go to the Linton military camp, which is on the far left. Some of them come to Massey, Fonterra, Ag Research, etc. Some of them walk from there to the traffic bridge, which is on the far right. And that was part of our strategy when that was being done 3 years ago, about the same time as our program, was to open the farm up to the public, because the track comes right through the middle of the farm as well. So instead of hiding away behind big fences, to say, here's where safe, quality food comes from, with a high standard of animal welfare, etc., etc. This is what farming's about. We're one of the most urbanised countries in the world, as is Australia. People now are very disassociated with where their food comes from. It comes from the supermarket, it comes from a factory. No idea of how it's produced. Anyway, I'm rambling now, so it's got shit all to do with my talk. But, so here's how we match the 3 treatments, and I'll go through them in a tick. Then the Pasture and Crop Research Unit, the soil scientists have run out of steam by then. They said there's only 3 soil types there instead of 5. The same idea, matching that up across so that sits just on the edge of campus, 5-minute walk from our offices, and right opposite our larger dairy farm. So we're able to block the treatments there, and there's 4 different treatments. So what are those treatments? In sheep, we've got our standard pastures, Ribos clever, with either contemporary or regenerative management. I'll explain what they are in a tick. And then we've got diverse pastures with either contemporary or regenerative management. Regenerative management was longer into, so we worked with Quorum Sense and other farming groups to say, let's define what regenerative management is, other than a mindset, other than a journey, which is really important as well. But what does it look like if a farmer's going to do it? Are you all just regenerative because you think you are, or are you actually putting practices in place? And I deliberately stripped out this idea of diverse pastures from other regenerative treatments. Even though diversity is a key and core part of regenerative, there were a lot more farmers interested in aspects of diversity on farm without changing necessarily a lot of other things. So, looking at that, mineral nitrogen input started off half and then now it's a quarter of the contemporary management, or going down towards zero, trying to wean ourselves off urea in particular, putting nitrogen on with a carbon source, those sorts of things. And that's the end. No, it's not. How do I get that back on? There we are. Wrong button. Contemporary management following beef and lamb and Z guidelines. Diverse pasture, 19 different things in there. And we matched that to our soil type and our animals. So we didn't just go say, let's put everything in. We said we've got a heavy soil type, which I didn't explain, sorry. Sheep farm, very heavy soil type, not free draining. We use underground drainage, mould and tile drainage, to move water off the paddocks. And things like bromes don't like low oxygen environments. There's no brome in here. Lucerne would do well in the soil, but also because it's a longer-lived perennial with a taproot, tends to block up the drains that you're trying to use to get water off the soil. So no lucerne in here. Standard pasture, ryegrass with white and a bit of red clover as well. Dairy, we dropped one of the treatments. I can tell you why if you're interested. But the same regenerative management, contemporary management following dairy and Z guidelines, 18 different legumes, grasses and herbs, bit of a slight mixture here because of the animal type, because of the soil type. Standard pasture. And then, to justify the money that we're being paid, we said, let's look at measuring and monitoring pretty much everything we can within that system. So right at the centre of this is the farmers. We want to go back to the days where farmers led the research rather than researchers leading the research. Or certainly at least farmers informing the research strongly around, here's the stuff that's important to us, rather than me going, here's the shit that's going to make my career. Or I'm interested in this stuff, so I'll keep doing it for the next 40 years till they make me redundant. So engagement and extension around engaging strongly with farmers, engaging strongly with industry, and with iwi, which are the sort of crown grouping of Māori hapu or tribes. Measuring all the usual stuff we can with animals, right through to the meat and milk product quality, so taste test panels and processability of the product, greenhouse gas emissions, nitrogen cycling, live weight of animals, rumen microbiome through looking at the dung and the animal, how we're changing that, reproduction, health and welfare, pasture production, again all the usual stuff around growth and pest and disease monitoring, quality and health, seasonal quality, composition. We're using things like near-infrared spectrophotometers, which is a standard thing in labs, using light to look at quality. We're also using the benchtop FTL Fourier transform infrared, which is a wider spectrum. And we're using normalised difference vegetation index, which is again a thing that we stick on. We've got a handheld one, we've got one that goes on a drone, and we're looking at measures of pasture health. That just measures greenness, that people relate that to health in the vegetable and horticulture industry. We're looking at whether it means anything from a pasture point of view. We've got the largest array of mini rhizotron tubes in the southern hemisphere, if not the world, which started out being a brag, but is just a pain in the arse because it takes you more time to monitor than we've got time. But they're just putting tubes in the ground, we can put a camera down, and it takes a series of photos of the root system in situ. So every other root measurement we do, we've got to disturb the ground. Every time you disturb the ground, you change the environment and you change the root system as well. So having less invasive stuff like this, you can put it in, come back 8 months later, and then measure every week or every month after that, if you like, around what's going on below the ground. Also picks up earthworms and some of the fungal activity and some of the little bugs underground, which is cool. Soil, which Luke's going to talk about, visual assessment, earthworms, as well as microarthropods and mesofauna, at least we'll tell you about them. Microbial DNA, so trying to get a handle on what's below the ground in there. Soil carbon as well. Soil physics, looking at a whole bunch of stuff. We've got about 110 grand worth of soil moisture monitoring gear across the sites, looking at every 10 centimetres down in the profile, to about 1.2 metres on the dairy soil, down to 60 centimetres on the sheep soil, because we've got a hard pan, we can't go any deeper. And then the nutrient leaching nitrous oxide, and we've just got another bit of gear that Massey brought that we'll be able to look at carbon dioxide coming off the pasture as well, which is a key part of that carbon cycling, as Lynn pointed out. So, what are some key findings and learnings? There's a beautiful diverse pasture on the left, ryegrass clover on the right, and we also look at diverse crops, summer and winter crops. And the sunflowers, they don't do much, but they make people happy. What we found is, of course, Mother Nature, which a number of people have said about different sites. And we've got mild temperatures. You look at the last 30 years, we're not seeing winters like they did for the previous 60 years. So we're in a different phase now of milder winters, more pasture being grown. We started the program with the driest autumn in 46 years, and then we had the wettest winter on record. What that meant was a tale of two farms. The sheep farm, it's heavy soil, pasture was slow to come out of the ground, we were struggling to get to graze it when we needed to, so it was getting overgrazed, and we had some issues there. The dairy farm, that's free draining soil, wettest winter on record also means the mildest winter on record, no frost if it's raining and there's cloud. We couldn't keep up the pasture growth, so it just boomed and loved it. And the more rain it got, the more it drained away, and the more the plants said, fantastic, let's go. Alright, so new pastures yielded more than the farm average, no surprise there. There's a thing called seedling vigour when you put in a new pasture or pasture mix in. And we made lots of silage. Interesting, lots of high quality silage. Pasture that was in the diverse pastures, waist high on there. Lots of legume, lots of herb, still at 11.5 megajoules. Wouldn't expect that to be with a grass dominant pasture over time, 11.5 megajoules waist high. But we made lots of high quality silage, animals ate lots of high quality pasture. Diverse pasture is a bit slower. In the cooler months, faster in the warmer months, they peak in December compared to November with the ryegrass and clover. So there's an implication maybe for our calving and lambing dates, unless we want a longer period of deficit. They out-yielded standard pastures in the first couple of years. 14 tonnes roughly of dry matter from our ryegrass clover and 18 to 19 from our diverse pastures. Some of that's an artefact of our measurement though, because particularly with the much longer rotations, lots of seeded, lots of stem, so less utilisation by the animals. So great, we grew an extra couple of tonnes, but the utilisation was lower. So there is that balance, as a number of people have talked about. Same milk production between treatments because we were being conservative, making sure animals were being well fed throughout. Pasture only system, or pasture and silage only system, with a few crops. So no other boarding feed. Different milk fatty acid profiles and a difference in the taste test of these pastures. But the Ritter Institute, I need to follow up a little bit of them of exactly what that was. There was a difference. There may have been a preference for the diverse pasture milk. Bear with us on that. Similar pasture now, but diverse pasture starting to yield more. We've got a dry summer at the moment. The sheep, as I said, that were set stockwood and have good pasture growth data from year one. No effective treatment on land survival, which is good, because one of the things of looking at the animals and system was saying, are we doing no harm by having a different system in here? Faster growth of the lambs, and again, a lot of farmers do that. Keepers like to finish the lambs off. I'll leave that there. No, keepers like to finish the lambs off on herd and legume pastures. And so that's what a lot of farmers do in standard practice. So this was just saying, okay, maybe instead of having specialist legume and herb pastures that don't last very long, can we incorporate more legumes and herbs into your standard pasture base? Surplus diverse pasture, and we've incorporated cattle in year 3 because we're with a sheep only system. And then a lot of New Zealand sheep farmers actually have, more sheep farmers have cattle mixed into the system, either grazing together or grazing after the sheep in particular. And so we're incorporating cattle in these farms in year 3. Right, same as there. Botanical composition, oh, is it 5 minutes or 2? 2, shit. Botanical composition, yeah, I'm going to summarise all this. There's quality, there's nutritive values, more non-structural carbohydrates and more sugars in the diverse pasture, and more minerals in the diverse pasture. What minerals? Calcium, phosphorus, and what's that bottom on the left? Oh, zinc, of course. Think of things like facial eczema when you've got longer pastures, leaving more behind. Sheep farmlets, the same story with sheep farmlets. particularly in the autumn. Sorry, what I've done is we've grouped it by season: spring, summer, autumn, and then the fall farm that's in that. And I said I'll summarise this. This is just to show you I've actually got some results and to take you off looking at my face for a while. Calcium with the sheep throughout the year, zinc, huge impact, copper, and then also a bit of an impact on selenium as well. So, summary of all that. Most changes we've seen above and below the ground are associated with diversity rather than management. Simply having greater diversity in pasture so far is driving most of the changes that we're seeing. In the diverse pastures, less grass, more herb. Herb was replacing the grass in terms of a percentage basis. Similar legume content throughout, even though we had lots of legumes going into the mix. A trend for more dead material over time under regenerative grazing with the longer rotations and longer residuals. And the trend means it's not significant so far, we're just seeing a pattern of it, right? But I'm putting that out there. Lower weeds with greater diversity. The gap fillers that a lot of the diverse species, particularly the herbs, and they were taking the place of things like thistles and docks that would normally come in. So again, that's pretty cool. Well, the most significant changes in terms of nutritive value, like I said, higher non-structural carbohydrates, more minerals. Rising plant meter was able to be calibrated for diverse pastures, which is cool. That R squared is as good as what we've got with standard pastures from the historical studies. So that's pretty cool. A rising plant meter tool that some people use can be used in a diverse pasture as well. Ecology 101, this is no different from 120 years of other research. We put in 18 to 19 things, we're still seeing 10, but 3 to 5 are dominating at any one time. Those 3 to 5 are the usual suspects there: ryegrass, red clover, cocksfoot, white clover, plantain. So we've got species that switch over from maybe ryegrass and white clover dominance in winter to cocksfoot and red clover dominance in the summer, with plantain hanging in there into our third year. We did a cutting study with one of the postgrads, 4 different heights, 3 different rotations. Those 5 were the most plastic, what they call the most plastic, most adaptable to different managements. So that reflects their breeding, it reflects their morphology as well. One of my take-homes would be not to focus on the number of species. People are arguing that you need more than 30 or 40 or 50 or 20 or whatever it is. I would encourage people to think about the functionality they want from pasture. Is it more even production? Is it summer gap? Is it deeper rooting? Is it ground cover? What's the function you're after? Is it greater quality at a certain time? And then work from that to specify something for your farm. All right, this is very quickly thoughts. Greater diversity under mowing is what all the historical research says. Lots more diversity under mowing. So when you're reading about stuff about diversity and lots of hyperdiversity lasting 5 or 6 years, it does under a mower, doesn't last as long with grazing. More reduction in diversity with higher stocking rates, and with sheep than cattle. So cattle lower stocked. I'm not saying 0 stocked or half stocked. I'm just saying that's what improves diversity. You know that varies spatially within your paddocks, and it varies temporally between seasons, years. Things pop up over time. And also, all of our different paddocks look different. You know, we've got sandy banks that you swear we just sowed lucerne into, because it's just thick with lucerne, and you go down the rest of the paddock, same amount of lucerne was sown there, not as sandy, not as dry, and the lucerne's just part of the mix that's in there, only about 2%. Yield plateaus after you've got about 4 to 8 things in the pasture. Animal performance plateaus are, and this is only performance and yield, there are other reasons why you might want diversity. Animal performance plateaus after 3 to 4 things. That's mostly legumes and herbs. They all take up the similar niche, so once you throw another couple of legumes and herbs in there, they're all fighting for space of the ones that you put in there before. I'm nearly finished. Each species needs to have a high enough population to have an impact, so it needs a time to shine, whether that means flowering, seeding, setting a decent taproot, all those sorts of things. Otherwise, they're unlikely to contribute much or persist. That's Ecology 101. You know, they need to fill their niche. If they can't perform their stuff and fill the niche, then they're not going to hang around for long. And diverse pastures are likely to require different management. Thank you, and goodbye from the founder of Harmony team.
Well, we expected you to go 10 minutes over, so that was a bonus, Danny. Again, I think we could sit and listen to you speak all day. What a depth of knowledge, experience and information, which really rounds out another powerful session. How good was that, ladies and gentlemen? Another round of applause. Now, before we throw to Q&A, and I know there's a couple in the crowd already, just a reminder, if you'd like to know more, and I know you do, be sure to scan the QR codes that are sitting in front of you on your table where you can find those abstracts. They'll also be available online after the finish of Grounds for Growth. So watch out for that. Okay, open to Q&A. Who have we got first? Yep, one there near Shiraz. And just your name and where you're from, if you could, please.
Yep. So Rachel Campbell from Agriculture Victoria. James and Danny, I know you're only part way through your trials, but what do you think is next? What are you going to be looking at next?
For us, we're going to push our systems harder. We've played it safe as we've worked our way into this. We've worked along with farmers in it. And so, you know, you're not likely to see systems level effects unless you're pushing the system. That the regenerative guys we're working with are a little bit nervous about that, but whatever pushing the system means for them versus pushing our contemporary system harder and a diverse one managed contemporarily harder. So what that means for us is maybe more aggressive weed control, higher rates of nitrogen fertiliser in our contemporary systems, and then looking at how that shakes out. We want to push our systems to breaking point if we can. Because like James says, it's a lot easier if we're publicly funded. We need to be taking the risk, not pissing around playing it safe. So we've found our way into this, worked our way in nice and easily. Now's the time to hit the straps and push it a bit more.
I suppose with us, we're wanting to probably understand a little bit more around the actual grazing management. So currently we're treating our grazing management across our farm is fairly similar based on our knowledge of conventional grazing. So we are seeing some challenges with Farm at 4 in terms of what the length of rotation should be based on the variety of species that are there, or a mix of species that are there. We are doing a lot more measurements around soil health, but we want to understand some of the impacts on the living system there and what potentially might be driving what is happening. And then the other thing I think we need to do is, this is all being done under a fully irrigated system. But we see a lot of the advantages of this will be in some of our dryland or runoff systems. So one of our, I suppose, key desires will be what can we see perhaps in a dryland type system to complement what we're seeing in terms of our productivity in our irrigated system.
Good stuff. Thanks, James and Danny. I think we've got another question from Scott, maybe, and then we'll come to the next one towards the back.
Yeah, Scott Hamilton from Western Australia to Peter and Kate. Can you see an opportunity to use less water on your multi-species paddocks?
Yeah, that's a good question. And yeah, we do believe we can. We've got soil moisture monitors in there now. We're going to talk about it tomorrow, the results from those. But we've also got a bit more funding for a trial where we will be measuring the water runoff the bays, and also just basically get more of a handle on where the water's going, how much water will hold in the profile and that sort of thing. So we're hoping to get some real results on that.
Comments, Kate? Happy with that?
Peter's done an excellent job.
Perfect.
Another one for Kate and Peter. Just curious about how your discussion group has received the data that's come out of your farm. Thanks.
So the discussion group whose data we shared today are a very highly focused on financial group, and they really haven't been all that much interested in the results that we presented today. I think they're just used to us being a little bit different, and every year they say, I don't know how you do it, your numbers are really good, but you're just a small farmer and you're not really kicking goals in terms of really high numbers per cow or anything, but our profit margin is pretty good. So I think, the figures the other day, our farm EBIT is similar to a 400 something average herd, but we're only milking 320 cows, just to give you an idea of sort of where that's sitting. But no, like it's more just on the whole farm profit and stuff we've discussed, so yeah.
Evidence speaks for itself, hey?
Just a bit more on that. Some of the guys, yeah, they're pretty focused on profit, but there's a bit of a group around our area, including these guys in that group, who are starting to use foliars through the winter, and they've been able to reduce their nitrogen inputs from say 300 down to the 180 mark by using these biological stimulants as well as liquid nitrogen through the winter. So it's quite a good win for considering they're so focused on profit, and it is more profitable for them to do that. That we're also reducing their nitrogen, which is a good thing.
Good stuff. Thanks, Peter and Kate. I think we might have had another question on this left-hand side, did we? Somewhere near you, Lindsay, did we? No? All good? Okay, over to you, Shiraz.
Yeah, Andrew Jenkins, Western Australia. Probably a question for James. The Farmer 4 extra nitrogen that you found, which you probably weren't expecting initially, what role does quorum sensing play around that?
Sorry, what role does what play?
Quorum sensing. In terms of, as you increase the diversity in species, I can probably get away with this room and talk about plants talking to each other. The communication between cells in the plants and how that might possibly enhance nodulation and I guess the sequestering of nitrogen.
It certainly could be a possibility. We certainly haven't considered that in terms of our management at this point, or in terms of our measurements, I should say. But it is an area of interest. We've got some PhD projects going on at the moment that's trying to understand what's happening at the root level, under the ground, in terms of that biodiversity and what that might contribute to the system. We have a fully irrigated system where our roots are probably limited to that top 20 centimetres. We don't see the advantages of some of that diversity within our fully irrigated system, but yeah, there's always a possibility, and that's certainly something of interest.
Right, question for Gillian, and I'm just thinking when you said roots limited to the top 20 centimetres, how did you feel about that, Gillian? In terms of you're farming some challenging country, right? So your slide where you showed the taproot going down into, I'll call it the stony layer.
The stony layer, yeah.
It's an opportunity, right?
Well, I found it really surprising. So basically, we've changed over to, if you're, I've got the kids and I'm going out and do walk in the farm, I'll bring a spade with me, and you learn a lot by sticking a spade in the ground every time you go around, because you start to tune into, oh, that looks better, that looks tighter, that looks, oh wow, look how far down those roots go. And I'll show some photos again tomorrow of what the comparison between, what those additional tangible benefits between ryegrass and multi-species are. And I think that it's not that there's a place for, you should have 100% of multi-species on your farm. I think if you find a reason to put them in to solve a particular issue. And I think that, find a place for it, make it work, and that's where you'll get benefits from it.
Fantastic. So another question for you, Gillian, before we come over to Kath. I notice you're very busy. You take a very evidence-focused approach to your farm business. What about what people think or say around you, your farming friends, farmers in the region, that sort of stuff? Because you've obviously taken a different journey, right? What's everyone think?
Yeah, when we started farming, we went once a day back in 2009. People thought that we were absolutely barmy, like they thought we were just crazy and lazy, and I really couldn't care. Like, as long as you're making profit, that's the most important thing. So, we continued going and working with every farm has different challenges. Work with the challenges you have in your farm and design your farm system around that to be profitable. So we designed our farm system around a very challenged farm to be consistently profitable. The results speak for themselves. I couldn't give, flying fairy about what anyone would say, and lots of people do talk, but all we do is we open our gates, we take in, I'd say we would have, we could have 10 groups over the year, discussion groups from all across the country, And at this stage, everybody's come in, we're all very clear and open with our financial figures, very clear and open with the challenges that are on our farm. And we can answer any question that comes at us. I'm in 3 discussion groups, our local discussion group, no different to your, they're very profit focused. And we always hold our own in it. And more challenged years, especially like in 2023, it was recovering from a high milk price year. And there's nothing like farmers taking a long time to recover from a high milk price. Everybody was, so we were, in terms of profit, we were very much at the upper echelon of our performance for our local discussion group.
Gotcha.
But when it comes to maybe having a very high milk price, which looks like this year will be, maybe we won't be at the very, very top of the group, but we're going to be across the board every single year, we're going to be consistently profitable.
Perfect. I particularly liked Kate's hand gesture to demonstrate nitrogen response, so that might be appropriate in that sense as well, Kate. I've already texted a photo of that gesture to Fee Smith just to round out the conversation, so I suspect I knew where that came from. Thanks, Gillian. We might throw to you, Kath. Your question.
Yeah. Thanks, Greg. Kath Lesbian, Dairy Australia. Thank you all very much for your presentations. I think it's been a really great session. Kate and Peter, you talked about data and providing that confidence that you had to make that move beyond, doing a few paddocks and that sort of thing. Gillian, you also talked about having that evidence and having the confidence, therefore, to do that. And Danny, you talked about the correlation of the plate meter to the to multi-species pastures and being able to determine what your dry matters there are. So a comment from any of you, but what would your comments be to farmers in the room to say, yes, go out and get those measurements and have some data and have some evidence to give you the confidence to move on or make some changes on farm? Has anyone got comments on that?
Well, what we'd really love to see our researchers have a big fail because they push the system really hard. Most of us in businesses can't do that. So what I would suggest is that you choose an area that, if it's a complete fail, won't crash your business. And when you can prove what you're trying on an area that doesn't crash your business but gives you the confidence to take it across your business, then you're ready to take that risk.
Yeah, I would echo that. You can see we started on the most challenged field where we actually couldn't lose. It made no sense to continue with doing the same thing and expecting a different result with ryegrass and high levels of nitrogen. So choose your first paddock wisely in an area that you can't fail. But you have to be brave. There's lots and lots of research to back up success with multi-species, and loads in Ireland, loads of research. There's full farm, dairy farmlet system trials to back it up. There's trials in dairy and there's trials in beef, there's trials in sheep. It's to show that it is there. The only trouble that I keep consistency seeing is persistency, but you guys have addressed that with the consistent oversowing of your pastures. So I struggle to see why anyone couldn't give it a go on a small area.
Perfect. Any final comments, James or Danny, on that one?
No, obviously measurement's extremely important to understand what's going on. We're measuring so many more things than what I mentioned because we want to understand what's going on. We want to try and work out, where are the things that are leading to the change and what we can do with that going forward. Researchers to some degree are perhaps a little bit conservative at times. I think it's people out there who are the systems experts are the ones who are driving change, and I think we can help to support that by doing some very controlled studies that help to provide a lot of data around that. So we've got the funding and the resources to be able to do a lot more measurements perhaps than what you do on farm, but then that gives us the confidence. And also it raises some more questions that we can then continue to look to explore going forward. But we certainly appreciate the systems experts when it comes to systems type research, and they're feeding into that.
Danny, comment?
Keeping it under 30 seconds. Just have a go, I think. Farmers are great at trialling new things, which is really cool. I'd encourage you to think about what you're trying to achieve before you just get out and have a go. The one mixture won't, or we're talking about diversity, the one mixture won't solve every issue everywhere. So there'll be something great that's going on down the road, or you've heard from a case study farm or from a research project. You may well not make that work, but you can make something else work. But really be clear about what you want to achieve from it. For us, it was backing off on nitrogen, so we needed legume in there. It was having summer production, so we needed things that were more summer active and with deep roots in there. But we didn't want to have a summer active pasture then open up a winter feed gap, because that would have just screwed us somewhere else. So we had to have a sort of a pragmatic approach to it, which you guys have as well, in terms of how you thought through what your problems are and how you might go about solving it. So I think that sort of pragmatic, step-by-step approach of what you're trying to do, listen to other people, and then have a go at something.
Righto, I'm just mindful that we are actually well over time. I know there's a couple of questions in the crowd, and unfortunately I won't flick to you on this occasion, but I do encourage you to connect with the speakers over lunch. We will reconvene. I would like everyone back seated at 1:25, ready to go for 1:30, please. Just to finish up, big round of applause for a fantastic session.